Getting back to it, I passed out some protractors. Some people got the first part of the circle. If you don't get it done right now, that's okay. I know it's You're going to put some of the numbers on it, and we're going to highlight which numbers we're putting on it. The other thing you need is a what am I calling this?
The diameter?
The straight edge.
Oh.
You need a straight edge too?
Straight edge.
Oh, we need it.
It's a very heavy duty ruler.
So we don't need no. That's the thing that got like a
Not
tech.
this quite. This is an assignment on there. No.
Go straight away, is that it?
It says unicycle construction. She's filming it too. I'm filming it. No, I'm
No,
filming
he's
it.
posting. Okay.
He said Coach Jesse said. But he just
I'll
told me.
post
No.
Yeah,
No, she not here.
what's your start?
All right. Miles and everyone, we're back at it because you do need to make a unit circle and you do need to know it. So I drew a diameter utilizing a straight edge. This is just a ruler. And there's certain angles we're going to measure. Remember, I said we go, which one is positive?
Counterclockwise.
Counterclockwise. Negative is
Clockwise.
clockwise. Where does our zero start now? That's going to
At
get
the top.
Sounds kind of
Right there.
at 3 o'clock.
Yeah.
That's Jaden Tyson.
Huh?
It's not right there.
That's what 3 stuff.
3 o'clock is
Who was Tyson Moses?
picture right, right?
4 is like a little bit.
His last name is Moses.
How do we go to line in the middle?
That is where we start our zero. Kind of because this is quadrant. What quadrant is this?
1,
2, 3, 4.
Notice how
1, 2, 3, 4.
notice how we went in the positive direction. If we went in another direction, we would be going like 1, 4, 3, 2, right?
yeah.
It never made sense while it was 1, 2, 3, 4, did it? But now it's starting to come together. We got 0. If we go all the way around the circle, how far is that?
180.
360.
Oh, completely around 360.
Here's where life gets fun. It's 0 radians, or if we go all the way around the circle, how many radians is that?
You said what?
Radians.
1?
2 pi.
I said 2.
I heard it.
I didn't know it was right.
Put that right on.
How do we remember this 2 pi?
180
What is this? What is that formula for?
circumference.
Circumference is
All the way around the circle.
around the circle, and it is 2 pi r. I started out saying, what are the 2 things we need to know about a circle?
Radius and diameter.
Center. We've got 2 pi r. That's our main formula, right? That's the key one. So that's the length around. It means that a radius, which is the distance from here to here, goes around the circle how many times?
2.
2
Pi.
pi. We're not going to change pi. Pi in and of itself is doing all the work we needed to do. It's like a converter for us. So let pi be. You following along, Jared? We got 0 to 2 pi radians. Notice on radians we don't have a symbol for it. They'll just say radians.
Just like the left back.
But if you're looking in a math text, so let's say we have like sine of 300 and sine of 300. One says degrees and one says radians.
Oh.
One has a degree.
One has a degree. Radians has nothing. So you got to be real careful about that. As y'all go into higher maths, most things will be set to radians because radians work better for math. So the radians, to remember how many radians are in all the way around the circle, we remember our circumference formula, which is 2 pi r, right? Doesn't it? So that tells us we go from 0
Ooh, my head.
all the way around to
So even if
2
it's
pi.
radius, then radius just regular number. Radius just a regular number.
Radian is a measure. It's an angle. It's like it's an angle, but it's more based on a length. It's weird. Huh? It's more based on. We can take a slight step back.
Wow, I could never do that.
You're so
Did you
skillful.
finish, Kelly?
My stuff would have went straight
We'll
outside.
go there. So we got that. We got 0, and then we got halfway across. How far is that at? 180. And then if it's 2 pi all the way around, how far is it halfway around?
Pi.
Feel like 1 pi.
You will notice now radians will start getting real simple because it's just fractions of a whole. But
It's gonna be
it's not 180 over pi.
We need just like that.
Oh my gosh, I messed up my circle.
I know.
So I stepped on my new Balenciagas.
So we got our. I did another mark on there. Which one? Where is that one located at?
Please don't step on my rough set. Go where?
So, where did I put that mark at?
In the middle.
In the middle, halfway between 0 and 180, right?
Yes.
Which would be at halfway between
90
0
degrees.
90. That's a 90-degree angle, right?
I said the first, but it's whatever.
My brain thinks.
90 degrees, right?
Yes.
Anaya, sit down. Your phone fell, I think.
Oh my gosh.
Pi is to here, correct? Where are you going? Why do we have so many phones?
Oh, I want to be from.
I'm gonna post that one.
Oops. Hope you need it.
It's cool. You can have your own.
Okay.
I don't mind it. You can set it up. You can do your own special filters and all that. I'm just saying, for those of y'all wanting one for yourself, I'm gonna just take that one and post it.
Please don't be
Halfway between 0 and pi would be a half a what?
A radian?
We'll make life even easier. So 90 was easy to spot,
Square
right?
root of pi.
We're doing radians now. We always got to do degrees and radians. Gets closer. It's pi all the way across, correct? We're going to divide pi in 2. And we're going to divide by 2. How do we do that?
Pi over 2?
We put it over 2.
I saw it said square root.
Square root is not half.
You so sorry.
You don't have to draw it yet when y'all get to take it. So we got pi over 2. We got one down here now, right? What's that going to be?
2 over pi.
Is that 270?
Oh yeah, degrees.
0, 90, 180. Plus 90 is
Yeah, 270.
270.
You say 17.
0 pi, radians. Pi over 2 radians. 2 pi over 2 radians.
2 over
3 pi over 2. 1.5. Now, I lost several people there, right? That's the same as 1, right?
3 pi over 2, ma'am.
Or we could look at it as this is 1.5, right? We got 1 and a half. 1 and a half, the normal fractions would be 3 over 2, right? Each of these is like an over 2. There is actually, if you see how we're getting this weird 2 stuff going on, there's an argument within the mathematical education community whether we should convert from pi to tau. If you want to get into the nerdy stuff.
You stupid.
If you want to. So we got that far? Are we kind of still going? We kind of caught up? We good?
I
You got it?
Yeah.
What's your name, Mr. Pillage? Oh.
That's funny. That's funny.
We got a good number the last time, didn't we?
Bro, I'm taking
I appreciate
notes.
it.
I'm taking mental notes.
Thanks, Mr. Coach.
What do you say, 5 and 3?
No, we're going to keep dividing it.
Oh, wow.
We're going to divide it down some more. So where do you think we might divide it down?
In the middle of the 90.
In the middle of the 90. So what's half of 90?
45.
45.
I know that.
So we coming from the side.
45 and 135, right?
Facts.
Now, obviously, these marks will be on the other side, but there's a reason I don't mark them. Why is that?
Because you already know.
Because when I draw my line through the center, the mark will be on the other side. I am lazy. I'm only going to mark once.
Who purchased it? Is yours it? Mine.
The thing I have is really awkward straight edge.
so talented. Perfect practice, no person.
Nobody actually play your football because no. At the end of the day, I hate to see it.
Okay.
Perfect practice, no person.
So, here we are. We've added 45, right?
It's like a shield.
Is that a pizza?
Starting to get there, huh?
Pepperoni?
Look, this how your boss does. You might take the roof.
That just wasn't nice.
Sorry, that's not a shot.
Ruler?
What's 270 plus 45? 315?
What you mean? I got the roof? You want me to chop the wood?
Now, I added the degrees in there. Is anyone looking at this wondering where the 45, the 135, 225, and 315 came from? Take 1 second before you go, I don't know. And look at it.
Well,
Does
she
it
said
agree
she
with
wasn't
an
finishing it.
increment?
So can you clarify her thoughts? Yeah, you added 45, but you got to keep going on the search 45.
You keep going up on the 45s, right?
Yes.
Now,
So
we're
that
going to...
half over there is telling you what's
Actually, you're starting to get it when people start memorizing the unit circle. They don't memorize the whole thing. Pretty much, you just have one part, and then you figure out your pattern.
You had a job line?
On the ones that I asked you to construct later on, I'll probably have you fill out or fill out.
Did we do a distraction?
Need a ruler? All right. So now we got to do the radians, which always cause problems sometimes. But this angle in half, right? This is pi over 2. What is half of pi over 2?
0.5.
Before we get any further, if I want to do half of 1, how do I do that? I write 1 over 2. If I want to do half of a half, I have 1 over
30, I thought it was 3 over
4.
talking.
Well, if I want to do half of a third,
1 over 6.
what did you say, Josh? I wanted to do half of 1/3.
1 over 6.
And Josh said 1 over 6. What did Josh just do in his head? It was real easy.
Multiply.
3 times 2.
Hey.
3 times 2. Any number, if you multiply the denominator by 2,
I'm not saying it.
you will cut it in half. Because you're just dividing it by 2. So if you have a denominator and put a 2 down there, you will cut it in half. Every time, okay?
Every time.
So if I have 10 and I divide it by 2, that's 5, right? Well, when a fraction is a little trickier, about 1/3 and I want to divide it by 2, I just put a 2 down there. And it's 1 over 6, right? So you just double the bottom number and you cut it in half. Useful. So if I want to cut 2 over 7 in half, how do I do that? That's 2 over
1 over 14.
2 over 14. It'd be 1 over 7. But, what's half of 1 over x?
2, 1 over 2.
1 over 2x. You just double the bottom
Now
number.
you heard it, itchy.
Pretty easy, isn't it? So this would be double the pi over 2. The 2 down there is pi over 4, correct?
What's Steve?
1 pi over 4, 2 pi over 4, 3 pi over 4.
Nice.
4,
5 power 4.
6,
7 power 4. That's right.
0 power 4.
So you
What your head look like?
can you say
You do look.
You'll have to review it later. I don't expect anyone in here to remember all this in one go. That's why we're recording it. We're going to do it several times, all right? Unfortunately, because I got to add in
The smaller increments.
more lines.
What is what?
Heavy duty now. Take care.
Jerry.
Oh, I'm sorry. I didn't-
But these, okay, so 180, what is it? 180 over what?
That's pi radians, not over. It's 180 degrees towards pi radians.
Okay, so
You got to realize each of these is 2 different ways of measuring it.
they
show like that.
high rating.
That's pi radians.
Okay,
Yeah. 5 pounds. The good thing is, I believe last year when y'all went through the unit circle sum, y'all do know
You got no fat on you.
it's kind of like a calculator, right?
Yeah.
Y'all did use it enough to recognize that it does, once you understand it, it like does a lot of work for us. So that's why we have to focus on it. We're gonna add the other angle measurements in there and the other lines today.
Today.
We're not gonna put all the sine and cosine stuff in here.
Thank God.
Unless we want to. Now we got,
Stop.
what are the other angles we have on them, do we know? 30 and 60. So to help us remember, you got the 0, 90, 180, 360, that's kind of where I start, right? And then I add the 45s. And you go up every 45. 345.
So,
Something like that.
is that the basics that you want us to know when you give us that food?
You're gonna get a blank unit circle.
Oh,
And you're gonna
man.
fill it out. It's not, you won't have to draw any lines.
I mean, but like, are you expecting us to know the whole thing when you give us that? Or are you expecting us to know
All
that
of it.
basics?
You know all of it.
What we give?
When you're ready, you're gonna get it. And basically, it's more of a, if you don't get it right, you're gonna retake it. On that one, the normal quiz that you're probably gonna get next, though, when I put next from the review, will be triangles. Just right triangles, basics. Maybe some conversions between radians and stuff.
Why you over here?
This is a little, we're gonna do, we're at 30 and 60 now, right?
Yeah.
So we can go every 30 degrees. 30, 60, 120, 150.
You got so much to think. This is you still like
Every 30.
You must say yours to the cleaners.
this would be 28 divided by 2. I know a lot of folks who just clean for that in.
Gonna start getting busy on the board.
No, my whole phone failed.
Who on this hallway has it?
What you want?
Better.
Oh, what?
He wants something to.
A shred edge.
Draw lines.
Oh, you just call it
The lady next door? Oh, you go there and make that tower.
That gets heavy for me to hold up there and do it.
You got most.
Miss Wise, they have made my Miss Wise, they have made my phone call so many times.
Olympus has fallen.
It's close enough.
Come here, horsey.
Dude, you gonna make them phone calls.
This is a polo sign.
Keep trying to follow along. You got the first part. I wasn't worried about adding more to yours.
You know how to
Do the whole thing.
You hit me with the amateur, now I'm gonna follow your ass.
You
No cap. When I wake up, I'm gonna follow your ass. That's a Morocco. Who? And I come here.
So, some people, can I see this?
can't nothing ever done.
Yeah, this definitely is not.
Some people are doing well with the 45s, and then once I start adding these, it starts getting a lot, right? Especially- What are we doing?
She's trying to hit me with
I
that
got the
hammer.
hammer so I can pay
No.
attention.
And she's making me
So if you're getting to the point on this next round that you're starting to get lost and a little, not quite staying as neat, just pause. We'll do another one. Just follow along. If we got up to the 45s, we're good. I'm going to go through the whole thing for now. Just see if we can keep track. So the next time we do it, we know a little bit more. It takes some practice. This is 30, right? So this is 30 degrees. Now I'm going to start running out of room on my board because I got to write it big. $30 degrees. These end up being tricky for y'all to identify the fractions. How many times does 30 go into 180? 6, right? 180 is pi radians, correct? That's gonna get way confusing.
They keep making it fall. And it's
Just sit up there,
irritating.
just
So 180 how many times?
6.
6. 180 is the same as pi radians, correct? So we're gonna divide that into 6 parts. So we do pi over 6. The best way for you to remember to keep track of this is once you have the 30 and this is pi over 6, we're not looking at the 45s. As you're going through this, make sure you skip these, alright? That's going to be important if we're counting like that. This is 1 pi over 6, this is 2 pi over 6. 3 pi over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6,
5 pi
5
over
pi over
6.
6.
6 pi. Just pi. 7 pi over 6.
I'm gonna get that.
8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6.
Yeah, and now they already have something there. It's nice to be able to count that way because these pi over 6s get confusing. If they already have something there, you don't label it. Or if it's like, this next one is 2 pi over 6, right? We can simplify that to pi over 3 pretty easy, right?
Facts.
So we'll call that pi over 3. We said this is 2 pi over 6, 3 pi over 6, 4 pi over 6, right? Uh-huh.
Can you step away from the board?
5 pi over 6.
Oh, shoot. We can't see the
You know, you're gonna mix the food back.
Some of you won't be able to simplify.
Smith is
The ones with the odd top.
DC Poo.
So,
Don't hit me. Oh my
if you're trying to find patterns, that's fine. The one's trying to not find it.
For real though.
Every single time,
my chick
the
too.
numerator here
Said
is
you
odd,
wanted to-
except if
It's
the
like
base
it.
is
You said every one of them.
I keep telling you. I don't have
So
a
this
balance.
is like 1,
You said you were gonna
1,
put 2 yesterday.
1, 1.
Said that last week.
This should be 2 over 3, right?
Last week.
You need to tell the lady who told me how much I got left to tell me how much I got left.
It would be 2 over 3, yeah.
If it's smoke, then we popping up.
Yeah, it simplifies afterwards. We know it simplifies. 5 pi over 6, 6, 7, 8.
Okay, I'm
It's gonna start getting way confusing, huh? You might be. I think you are. 9, 10, 11. No, 11 right here. We got them all marked now as far as the radians. There's a lot of radians, and I know that it starts getting confusing once we get to these 7s and 9s and 11s and stuff. That's why. How did I count my way through it? Did anyone share?
You
Anyone
asked
else
how
catch
many
it?
times that.
I just counted
Yeah.
1, 2, 3, 4, 5,
Yeah.
right? Because that's a little easier to do. You have to make sure you know which ones you're counting though. You're only doing them every 30 degrees. So that would be 30, 60, 90, 120, 150. The degrees are easy. 30,
Yeah, I didn't draw
60, 90, 120, 150, 210. And 330. Because the degrees just go up by 30 and then you're just adding it. No one ever has a problem with that. There's more to add to it. Why? Because we don't have any coordinates yet. Right now it's just a circle with angles. There's no more lines to add to it. How much time are we doing on time?
We got 15 minutes.
You said the first time.
The important stuff, right? We'll do the basics of the important stuff. We'll see how far we can go. I need to get over here real quick.
What's 8 pi over 6?
So we switching boards, Mr.
4 pi over
Wallace?
3 is
Wait, no, 8 pi over
in degrees. You add it's 240. What is this called?
A unit circle?
The unit circle. A unit generally means 1. It isn't technically 1, but 1 is sort of like a singular unit. Josiane. Makes sense? 1 is a single unit. which is very important. So if I have a unit circle, it has a radius of
1.
1.
Sorry.
Very, very important. You good on that? Unit circle has a radius of
1.
a unit square has a side length of
1.
1. A unit hexagon has a side length of
1.
It's a pretty common thing. I'm going to draw a secondary one here.
Chill, Jazz.
Horrible circle.
That's actually good.
And I'm going to put a triangle on this circle. This is a unit circle, so it has a radius of,
1.
what's the radius?
1.
1. Very, very important. You'll see them a lot of times with this triangle in there, right? Have y'all seen this? This triangle, this point right here, has coordinates x, y. Some set of coordinates, correct? You want to be tangent, it's like x squared, but there's all kinds of math we can get to it. We think of it like this. Imagine this is like a circle with a string on it or something, right? And if I take this point and go around it, the triangle will keep following it, right? The triangle will kind of and it'll be very consistently so. We're talking about one main angle on this triangle, and that is this angle right here. That is our theta. Theta just means angle, right? Right. So, this side is 1. This is the angle. This is a opposite, correct? This is an adjacent, right? We have coordinates of x and y, right? And what's the length of the hypotenuse? Why is it 1?
Because
It's the radius of a unit circle, right? So we're going to do sine of this angle, sine of theta.
We need to write this?
This you gotta have to like sear in your memory. Sine of theta equals opposite. Now let's pay attention to this opposite. This opposite also has this same distance, right? What is this? What did we label this distance as? If we're going to get to this point, we would go over some distance and up some distance, right?
The Y? We started, right?
Speak up.
I said the Y?
The y. We went over x and we went up y, right? So that coordinate is the length of the opposite. You good? So sine of theta equals opposite, which is y, over the hypotenuse, which is 1. So the sine of theta equals y. What did we just prove? They are the same thing, which is useful.
Oh, that's the thing right there.
Generally, if I ask you to do like, what's sine of 45, you got to type it in the calculator, right? Or you might have had charts. If we lay this circle down accurately, and we know our y coordinate,
Sine is y.
sine is y. The y coordinate is sine. In addition, if we do adjacent, which would be not y, but x, cosine of theta equals x over 1, right? So the x value is cosine. You good on all that?
You said X is cosine.
X is cosine, sine is y. That's really like the big thing to remember. So now when we add coordinates to this circle, running out of room, but if I add coordinates here, let's start here. These are the easy coordinates to do. We go over 1, right? Yeah. So that's an x value of 1. And we go up none, so that's a y value of 0.
What you mean go up 9?
Well, we go over to this point right here. We don't go up at all, do we? We just go over, right? We go to the point 1, 0. Because the radius of the circle is 1, right? 1 is like it's a set thing. So anyone in here, if you type into a calculator sine of 0, what do you think the answer is going to be? 0. Sine is y, cosine is x. Cosine, sine. We got that? So we want to know cosine of 2 pi, we would get cosine of 2 pi would be the x value on 2 pi, right? Which would be 1. This is the cosine value, this is the sine value for that angle. That's why when you look at a chart of a unit circle, you don't look at a calculator because it gave you the answer. So that's 1, 0. We're going to do 3 more points just to that. What's the coordinates at this point? 0, 1, because we start at 0 and then we go up 1, right? Yeah. It'd be handy to have more board space, huh? Middle school's got the biggest rooms ever. Like, I go over there and
Middle school big, the 6th grade academy, they board all the time.
they need all the food they can get. That's 0, 1. This one's going to be
1,
0,
0.
180.
we are on an XY graph, so if we go this way, we go in the
Negative 1, 0, -1.
negative 1, 0. And down here would be
Negative 1. Yeah, 0, -1.
0, negative 1. We got this far, might as well do the 45.
Oh my gosh.
Wait a minute.
That's just one, huh?
45s are easy because both the angles are the same, right? Because notice an isosceles right triangle, it's 45, 45, 90, right? Y'all have learned this, that's why I'm moving so quick on it. If this side is 1, we're not even going to bother with the proof just yet at this moment, we'll do it later. And it's a 45, so this is 45 degrees. This side and this side would be the same, right?
Yeah.
The thing you're going to remember, it shows up on St. R's testing all the time. Who's playing music right now? There's root 2 over 2. We've seen that before, right? That number right there. We've seen it. It is, that's what it is. That's why we see it, because it is the side of a 45-degree triangle. We'll go through some. What's going on, maybe? I don't know. I was like going through that one before we talked about the proof of the square root of 2 and stuff. So root 2 over 2 is going to be the measures for the 45s, and we're going to see this last bit. I'm not going to worry about 36. This one's root 2 over 2, root 2 over 2, right? Sine is y, cosine is
X.
x. So sine of 45 is
No, that was the one you did. I can't.
root 2 over 2. Cosine of 45 is root 2 over 2. Cosine of 180 is
0.
so cosine is negative 1, right? Sine of 270 negative 1.
Negative 1.
Yeah. Pretty easy, really, once we have all this information down, right? This one's going to be easy. You know how we're on a Cartesian system, right? Or X's and Y's.
Who?
That's the old way of calling the graph. Root 2 over 2, root 2 over 2. This one is going to be negative root 2 over 2. Root 2 over 2. Any questions where I got that from?
So why is it root 2 over 2?
I'll do a short lesson tomorrow on that little proof.
Oh my gosh.
Can we do that? Because it's all tomorrow. I'm saying tomorrow, not today. That's a whole nother pile of information I gotta put in there. So today, you just notice root 2 over 2. Tomorrow we'll go through life.
7.
It is my class. I just know that this is a whole massive amount of information to go through at one time. Root 2 over 2. This one down here, the other over 4. What's this gonna be? How about this? Hold up. Negative, negative. Remember your old sides. This one's positive, positive. This one is negative, positive. This one is negative, negative. We already know it's root 2 over 2, root 2 over 2, right? And we know the signs therefore are negative, negative, right? Positive, positive, negative, positive, negative, negative. This one is positive, negative. So when we get to the over 4 here, the 45, this one would be positive, negative, right? It looks like a lot to remember, but we only had to remember one number, right?
Yeah.
And then it fills itself all the way in the rest of the way. Yeah, that's probably enough.
Yeah.